Greetings. This is Graham Warren working with you on simulation scenario analysis for the Antico Caffe Greco case with the AnyLogic model. So in the previous clips, we introduced the case, explored some queuing analysis of different scenarios available, and also introduced the AnyLogic model. Here, we're going to simply change the parameters to entertain different process innovations and price this out, looking at utilization and the waiting time in system. The waiting time in system is a CX metric, and then the utilization could be taken as an EX metric. It testifies to how much, what the workload level looks like, what fraction of the day a barista is committed and working. So just one note, to run these models or to download and get them running, what I suggest doing is download the file locally. It's a .alp file. Open up AnyLogic, and then open up the model from within AnyLogic by just using this open functionality. Right, so let's jump into the analysis. So I've got the base case set up here. The base case is where we've got 7 baristas operating. They operate always at 150 minutes average per drink, per beverage. In the base case, they're using Jura machines, and the standard deviation of the service times are 5 seconds. The arrival rate in the base case is 157. Total customer load per hour is 157. We're dividing that by 7. So each barista has sort of dedicated areas of the cafe. They're seeing 22.43 per hour. So that's captured here. I really don't need a VAV time. Just make that a 0. There's no VAVs. There's just one Jura. And we run this. I see I'm actually running it as fast as possible. You could run it real time by changing that one, this setting here. Maybe we'll change. Maybe we'll just change it and run it like this. So let me do it like that, just so you can observe it running a little slower. Okay, so I lost that. Let's see if I can get it back. So just in the first one, I'll run it pretty slow. We can speed it up here or slow it down here. See, I'm running 5x and so forth. And then the key move here is to click on the gear to see, where you are in time. So I'm now at 96 minutes, about 2 hours. And you can see how these graphs are building. Utilization, it was a sort of the startup of the day, and now it's like a full-blooded, full-on high utilization period of the day. So we can speed this up all the way to the end and get an estimate. Runs out to 19,000 minutes. You can see I got an estimate of 19.48 on the waiting time. You can get a screenshot of this and maybe include that in 0.93. But I want to run this again because we're at a very high utilization here. 93% is rather high. So anytime you subject a system, any simulation system, to high load, the estimates are going to vary a lot. So here I got 1606. So now the question is, could you actually get a day like this where the waiting times are actually only 16? Sure. And then other days it's 19 or worse. So you need to do multiple runs here to estimate these quantities. We may get something there's an 1884. See if we can get something is it 21? If you do like 20 of these things, at some point you're going to get a day where wait times, there's a 31. Okay, that is a real day. It's a real day. So bear in mind that the variance here is a consideration, and it's something you could talk to. All right, so that's the base case. I'll take a look at just the pooling case where we do the base case, and then the only adjustment we make is pooling. So to do that, we go to 157. And we go to 7 baristas here. See, it refreshes when I hit enter. And I think everything else there should be fine. Now, I know that this one had around a 4.73 mean waiting time. Utilization remains the same. Let's just see how this is going to go. And we'll run this one fast again. So utilization ends up here, 92, 93%. And you can see I've got a 462. Again, run this again just to see how results change. So now 41, maybe one more. Just want to emphasize the multiple runs. The professional version of the software allows you to do multiple runs without having to manually do it. We're on the freebie version, hence have to run it. So this one's 529. You average out if you across a few runs, you report that. So that's the base case with pooling. How about base case with VAV? So here I'm back at having the baristas serve their own queues. There's 7 of them, but the service times run up to 30. The standard deviation runs up to 30 seconds. Let's try this one. So now I'm expecting around 21 minutes average, according to the queuing analysis. Let's see how this goes. What have I messed up here? I must change this. Excuse me, I messed that up. This should be 157. No, sorry. I've got 7 baristas in here. That's the issue. And we'll run this one to completion. So this one was about a 21-minute average. Let's see, so I got a 1644 day here, 91%. Let's run it again. So one VAV. Oh boy, my bad. So we're running a VAV here. So this should be a 0 and this should be a 1. Actually, it should get the same result. But let's make it let's keep it as labeled. So my bad on that one. Run this to completion. So 1 VAV, 30-second standard deviation. These are the untrained baristas. And just make sure we're at time. We're at time 1594 day. You can't quite see the utilization on that. Let's move this a little bit. I guess if I close this, no, it's not showing. It's unfortunate. Oh, that's just 0. Okay, 94 for the VAVs. My bad. All right, so let's run this again and just see if we get something approximating 20. So here we are with 21, right? Let's see if there's anything that looks a lot worse than that. 1796, 20.3. Just want to see if we ever get a 30-day. Yeah. Oh, nice day, 17 to 25. So this is something that you can talk to. All right, so the next one I want to do is I want to have these folks use a VAV. Wow. Okay. So I messed up the previous one. It was supposed to be 1 VAV with 30 seconds here. So I need to rerun that whole piece. Let's do that. Okay. A little scattered here, but bear with me, please. Okay, so this is base case plus a VAV, 1 VAV, okay? There's no pooled orders. We'll run this one out. This should average about 20 minutes. This was 18-minute day. And one more. 16. 22. Should average out. So you can see the utilization is 93%. All right, now we're going to train these folks. So now it drops from 30 down to 11. And we run. So lower variance should help. But let's see how much. According to previous analysis, we should still be in about the 20 range. So that one was 16. Run one more. See, utilization's up there. This was a 19-minute average from time of order to time of delivery, 17 minutes. And if you run a few, you're going to see something. There's a 21 and 19. Because of the truncated normal assumption in the model, we're going to get slightly overestimated results here. Results that are higher than the queuing analysis, but negligibly higher in my opinion. All right, so I want to do one compound one for you. What about we do the base case, and then to that we add valves. We have two baristas and we train them. So I'm going to go up to 8 baristas. So I want to have 150 divided by 9, excuse me. Let's just plug this in. 157 divided by 9. So that's 1744. We've got the valves, they're trained. And yeah, we just got one here because they're not pooled, right? There are 9 of them running, and they've got, each of them has got 1/9 of the cafe that they're serving. You know, we just divide up the tables accordingly. See how this goes. This one here was reporting something like about a 5.8 minute average W sub S using our queuing. Ballpark of 5 something here, 5.7, and utilization 74%, according to our analysis. Yeah, I didn't write it down here, but that sounds about right. So 70-some%. Let's just try 1 or 2 more. And you can see the utilization here. Pretty tightly clustered, and this one was a 632. So over 5, but I bet you if we run it a few more times, we might even get a 3 with a 576. There's a 6 even. And well, 595, it doesn't seem to want to go much under 5. All right, so I think that's it. There's a lot of possibilities here. You can run a lot of flexible analysis by changing these things. Maybe just let's try one where we let's look at pool orders. Okay. And we have 5 seconds on this. And let's try, so we had 7. So let's try keeping 4 of our, let's try having 4 of each. See how that ends up. So this is, this setup here is pool orders, 4 valves, 4 jurors, and the baristas who operate the valves are trained. See how this goes. So this is something you couldn't do with a queuing analysis, but I just want to give you a quick sense of some of the options here. So I don't think you can analyze mixtures of jurors and valves other than in the pooled scenario. Let's run this to completion. So here you're looking at 395, 3 minutes. 3 minutes, and the utilization on this thing, the humans are 90% utilized, the jurors are 76% utilized. The reason why there's a difference here is because the model goes after a valve before it goes after a juror. So if there is a, the valves are going to be consumed most of the time. The only way they would be idle is if there is no, they've serviced all the orders, okay, and they're just waiting for the next order to come in. But the valves are sort of first up, so to speak, in the model. Okay, hope you enjoyed this. Looking forward to seeing what you produce.